Hi, Tim Spann here. My talk is adding generative AI to real-time streaming pipelines, and we're here for the large language model conference at Conf42, which is always a nice one. Great place to be. I'm going to discuss a couple of different open source technologies that work together to enable you to build real-time pipelines using large language models. So we'll touch on Kafka, nifi, flink, Python, iceberg, and I'll show you a little bit of each one in the demos. I've been working with data, machine learning, streaming, IoT, some other things for a number of years, and you could contact me at any of these places, whether Twitter or whatever it's called, some different blogs, or in person at my meetups and at different conferences around the world. I do a weekly newsletter, covers streaming, ML, a lot of LLM, open source, Python, Java, all kinds of fun stuff. And as I mentioned, do a bunch of different meetups. They are not just in the East Coast of the US. They are available virtually live, and I also put them on YouTube. And if you need them somewhere else, let me know. And we publish all the slides, all the code, and GitHub. Everything you need is out there. Let's get into the talk. LLM, if you didn't know, is rapidly evolving. While you're typing down the things that you use, it's changed, right? So trying to keep up to date a lot. There's a lot of different models, and I'll show you it doesn't really matter how we integrate, because we could do it all through a couple different ways with open source. And the models, there's some closed ones we'll integrate with, some open ones. Which one makes the most sense for you? Depends on your use case, but we'll integrate with GPT-3.5. We'll integrate with Ollama running some models. We're running with Mistral and Mixtral. Working with Pinecone today and Chroma. Touch on those a little bit. There's a bunch of other ones out there. All of them pretty good. We do a very little bit with LangChain. It is used by some of my processors that are written in Python, which are integrated through nifi. And we're using a bunch of libraries like transformers and also Hugging Face hosted models, as well as models hosted by watsonx and some hosted by Cloudera. There's a lot of different ways to interact with models. We'll also do Ollama, which is running on my laptop, along with my whole open source stack. So I wish I had more RAM and maybe a GPU in there, but you do what you can. Lots of different use cases. If you're at this conference, you probably know them. We're not going to touch on all of them. They take forever. But the same ideas, though. Get your prompt ready. Send it to the model. Get your results back and do something with them. That enrichment, transformation, processing, all that you need to do around prompt engineering really needs tools so you're not handwriting everything. That's why we like to use something like Apache nifi, which I'll show you. Can help you with all of this, whether it's getting stuff into your vector store, helping cleaning up, calling multiple models. Maybe code assistant step 1, and then you need to summarize documentation and translate it into another language. Maybe you need to build some content, push it somewhere. nifi really helps enable a lot of those use cases. This is probably more important. In this decision, you could change. Maybe you start off with a closed model because they are probably the best at this point. They do a lot of good stuff, but then you're worried, can I get the data there safely? Maybe I can, maybe I can't. Is there data I don't want to be used in their models? Open source, because we love open source. We love these open models. That works really well with our ideas around open source tools for streaming. So it makes sense, but if that's not what makes sense for use case, make that decision. What's nice is with nifi, I can run, and I'll show you an example where I have like 4 or 5 different models in different locations that I could decide or not decide when to run. Maybe when one is cheaper, maybe when one is better for certain use cases. You make that decision. If you're going to do this in the enterprise, Cloudera works with AWS and IBM and Pinecone and NVIDIA and Hugging Face and Ray to make sure you can do everything you need to do to work with the foundation models, have the proper search and vectorization, have as much GPU-powered performance, all the right tooling, and run all the different compute options that you need. And again, the amount of models and projects and software as a service and open source tools that come available is massive, and it's changing constantly. There's new versions of things. You're like, oh, this is the coolest new model. It's like, ooh, Google Gemma is the new one. No, Mixtral. Now it's fun because there's always something new going on, and probably during this conference there'll be 2 or 3 new things. So I'm keeping my eyes open. I want to see what comes out. But the middle orange bar is where I'm mostly working, is getting that real-time ingest, enrichment, wrangling, transformation, all of that. Get that data stored, get the data to the model, whether it's for training, whether it's for context, for prompts, whether that's calling the model, get results back, get your classification. All important, whether that's in private cloud, public cloud, hybrid cloud. So maybe you need to run on Amazon, Azure, Google, and your own Red Hat Kubernetes. You could do that. Doesn't matter if it's Google specific hardware, AMD, really good chips, NVIDIA, IBM, Intel, Dell. Everybody's got good stuff that helps you out there. You just got to know that you're using the right framework and libraries and versions of Python and Java that are tweaked for those things. And we definitely have people that can help there. Get all your models out there and running. Common use case, and this is where nifi really shines for this process, is interacting with people and data. And for, automated tools, they may not know the difference. Now, you know the difference if you're doing live QA, and I'll show you that through Slack because you're typing it, but that data can be done by another bot. That data can be coming from a database. It can be coming from REST endpoints, documents, social media, transactions, public data feeds, S3 and other files somewhere, logs, ATMs, other live things, weather reports, wherever that is. We're getting that data in, sending data out when it needs to go out, cleaning it up, get all the enrichments, do any alerts that need to happen right away, get things vectorized, chunked, parsed, and into whatever database or data stores it needs to go to. Get it to the right models wherever they may be, whether that's in Cloudera machine learning, Watson, 100 other places. Get that into Kafka so we can distribute it to any information that needs to be shared and shared instantly with as many people in as many places as possible. We get it into Kafka. If that needs to spread, if that can't be accessed because maybe it's in a very secure internal Kafka, we could replicate that one to ones in the public cloud so it could be shared with other applications, systems. Great way to distribute your data quickly to whoever needs it without duplication, without tight coupling. It's a really nice feature. Get it stored, get it enriched, and we'll show you that in examples. And a common way to do that is CDC, and we can pull that CDC instantly, get it working. Like we mentioned before, get all those LLMs together. A common thing that we do as part of these flows is ingest what we're ingesting. And that could be, constantly a stream that's getting pushed. We're pulling it. It could be croned. It could be one-time grab, documents, messages, events, files, whatever it is. It doesn't matter. nifi supports hundreds of different inputs and can convert them on the fly. We can parse documents very easily. Thank you, unstructured IO. Chunk them up into the right size pieces so that it'll be optimal for your different vector store, or if you're pushing it somewhere else. I mean, the nice thing is nifi, I can send it to as many places as possible, get that into the stream, whatever we need to do there. The data pipelines, getting that external context when you need it. So I type a question, what is Apache nifi? grab some external context so I could pull all of my recent articles from Medium, get them cleaned up, enriched, transformed, parsed, chunked, vectorized, and available so that when I ask a question, if that's already there, I pull that, add that as a context with my prompt, clean that prompt up, get it in the format that's needed by whoever's model I'm calling. You know, a llama's slightly different from Hugging Face, REST versus Watson versus Cloudera. Get it in that right format, probably JSON, and make sure it fits, you know, make sure it's not too big. Get that to them, get those results back, maybe start caching at different layers. Maybe that goes into a database, maybe that goes into RAM, lots of options there. And do the round tripping for you. So you don't have to write an application for everything. You know, someone types something in Discord or REST or comes from Kafka. You can pull it from a database, pull it from Slack, and send the messages out, whether it's going to email, Slack, a database. Wherever you need it to go, we'll send it there. Pretty easy. And we can deal with all your types of data, even if it's zipped up, tarred up, if it's images, videos. Documents obviously is a big one for most of the use cases for large language models. So, but it doesn't matter thanks to unstructured I/O and some other processors in nifi. I could deal with HTML and Markdown and RSS and PDF, Word docs and Google Docs and RTF and regular text. And I added one to do VTT if you know about that format. Sound, any kind of the feeds from social, and XML too. And we can figure out what type it is, chunk it up, store it, parse it, do all those things you need with that unstructured and semi-structured data. Interface with whoever you need in the cloud or on premise or in your private Kubernetes. All the major ones. If it's not listed, it means we haven't tried it yet. Definitely reach out. I'm always looking to find new things to try and integrate. Fun stuff out there. nifi just got into version 2. This is the one you want to use. This will be official production release very shortly, possibly by the time you're seeing this. It's got hardcore Python integration, so I can run really cool stuff in there. Really cool way to deal with parameters in it, so you can do a lot of interesting DevOps stuff. Using the latest JDK, if you're not a Java person, that one has a lot of enhancements that makes Java incredibly fast. If you saw that 1 billion row challenge out there, really cool stuff there. And just to show you how fast it is. I also recently found that we can do real-time integration with models while we're running real-time SQL. Flink SQL is a real-time SQL on top of fast data, such as Kafka, such as Pulsar, such as real-time streams. And we can also grab data from things like Kudu and Iceberg and JDBC stores like Postgres, Oracle, in real time or through CDC. But what this means is by writing a simple function, I can call a model as part of a query. And I'll show you that. It's really cool. And I could do that whether I'm doing that directly to something like Cloudera Machine Learning, or if it's something that takes a little more enrichment, like that process we were mentioning. So I'm going to have nifi host a REST endpoint for me. So I can have this tool call that, and that'll do all the cleanup, make sure your prompt is nice, and send that over to, say, Hugging Face and gets your results, and send them back to you so you could use them in your live system. Got a link to the article here and an example of the SQL that we have there. Pretty straightforward. Like I mentioned, I'm working with the Gemma model, so you can access that. Take a look at that example. Again, the difference for using one model versus another, not really that much for me. Now, I mentioned being able to use Python. We'll go through that pretty quick. If you saw the Conf42 Python, I explained that in detail, how to build your own Python processor. This is that VTT I told you, so I can parse that. So we can grab those web video text, use that to either put in your vector store or enrich prompts or other stuff. We can call Watson right from there, create our own fake data, grab Wikipedia feeds and get them in a clean format. Very nice, saves a couple steps there. This one is important for me because I found sometimes I want to pre-process a prompt. And the reason I might do that is someone might ask a question that I don't need to send to a model. Save me some money, save me some time. If you don't need to use a large language model, maybe use regular ML or regular small model, or in some cases, just do a REST call. Like if someone goes, what is the current stock price for Amazon? Don't send that to ChatGPT. So I parse out the company names with some cool libraries out there. And then I could do another thing where I can look up the stock symbol, get the current stock price, and send that back. That is faster and cheaper than calling a language model, even on premise. And I have that in some of the articles. It's very easy. Now, I've also added a new library using Salesforce blip image captioning to be able to generate captions for images. Because remember, I could have flows full of images. And I use this as part of parsing out things when I do meetups. And I think it's generally useful thing to have. And I could change the model if there's a better model for that. I also added one for ResNet 50 just to do classifications. You know, pretty useful for flows. Again, as part of that multi-step process, I might want to caption an image. I might want to make sure it's not a problematic image. So I'm using this one to make sure we don't even deal with those. So we just delete them. Maybe I need to see people's face in the image. Again, getting more data could be helpful before you send things downstream to other models. And again, there's Python processors to do chunking, parsing, calling ChatGPT, working with vector stores, just to give you an example there. Let's get into some demos. I just got some links to some other articles here. But let's get into the demo. You don't need to see any more slides. You will get these slides, and they are fully available for everything you need there. So no problems. Very easy. So first thing we do is this is nifi. It is running for us. And what we can do here is, you know, if we wanted to build new stuff, we can add any of these processors. If you want to see the cool new Python ones, just type in Python. There's a bunch of them as you saw in the list there before, like extracting company name, just to give you an example. So what we can do is, well, I want to get a meetup chat going. So I have a processor here that just listens for events as they come from Slack. And there's a couple tokens you got to set. I have an article that shows you how to do that. It's very easy to set up those. So here is my Slack group. If you're interested, you could join it and you could use it to ask application questions. Let's see if it knows this one. I don't think it does. When is the Conf42 large, should I do LLM conference? So what happens next is it comes in here. As you can see now it's running because it just got messages. And just for fun, I store them in a database. Oh, unless someone stopped this. The nice thing with nifi is you could start and stop things either manually as you see through this or through a DevOps process that could be REST or command line. You get the idea. But let's make sure that data went through. This is data provenance. This is really good because I don't know what that black box LLM's doing, but I could tell you exactly what I did to prepare that prompt, when I sent it, how big it was, and what I got back. So you don't have the provenance inside that model, but I know the provenance getting there and coming back. So that can be very helpful. So this is my message here. It's me because I typed the message in. There's my input. There's an ID, timestamps, where I am in the world. Helpful stuff. So that message went in. I saved it in a Postgres database. I also pushed it into Kafka for Slack messages, and you'll see why when we get to that next step. So we've got that data. Again, we're using two parts of the process already. And then I'm going to do the the prompt cleaning and engineering. So I'm just going to pull out the fields from that Slack message that I want. If this is coming from something else, you might have a different extraction, but pretty easy. I make sure that it's not myself. I don't want to reply to the reply we send to it. Filter this out. I forgot to mention this model. There's a model from Hugging Face for not safe for work text. So I want to parse them out. I don't want those. Oh, someone added another step here. Yeah, I was running a demo. I wanted to look at those. We're just going to delete that, which is the awesome thing. Then we start it up. We have these configurable queues that run even on a big cluster, and then make sure things don't go somewhere. Ooh, one of the questions was not safe. So that didn't make it through the system, which is fine. And here we're going to query Pinecone with that input, see what we get back, extract the results there, build up our new prompt, and then figure out who we want to send it to. Do we want ChatGPT to get it? Do we want someone else to get it? I've been just doing Mixtral most recently, but I also have Mistral running on Olama. And down here I've got Google Gemma running. Again, pushing the cleaned up prompts to Kafka as well. So we come into here and we format the prompts exactly with some instructions added. You kind of need that for Mixtral 8, 7b instruction. I mean, every model is a little bit of different tweaking. So then we call it, and if we look at the results here, we could see what we got back from there. And then I'm going to clean it up, add a couple fields, and push that into a different topic, and also push that out to Slack. While I say this, we got our threaded result back, and see if it's any good. Conf42, April 11th. Oh, and it's got the link. Wow, look at that. Okay. I must have had that. Remember, we looked into Pinecone? Well, that's where I put my medium. And in my medium, I've linked to the conference because I'm speaking here. So I like that. Pretty good thing. So we got the data and we got it back. And like I said, we could have sent it there. Could have sent it to Watson, Google Gym. Lots of different options here. To get things back to Slack, I have just a little cleanup. And I just, add that generated text. And I push it to the right channel. This gives me the right timestamp, so I'm in that thread. You don't have to thread the results back. I put a lot of extra metadata in here just for myself. I don't need to put this here. As you can see, it tells me what model, how long the compute took, all those sort of things. So if you see that, this is just metadata for me, or just to be interesting. Oh, it was Mixtral. It took 100 tokens, that kind of stuff. We could filter that down if we don't. So remember I said I push stuff to Kafka. Let's get there. These are these Kafka messages I pushed out there. Well, I can do real-time queries on them with Flink against those Kafka messages. And if you look here, as part of that, I'm passing in that message text and sending it against a function, which is this function here, which calls into nifi to get the results back. And then we get, there's that Kafka we saw. So it is running and getting the generated text here, which are results for that. And you can see the Flink job is running. If I had a big cluster, it could be running there. Not much going on here, but I have a materialized view. And what's nice about that is it produces all this data as a JSON REST endpoint, so I can ingest it somewhere. Now, like I mentioned here, that USB is calling out. That is calling out to another process here. And this is how nifi acts as a whole website. So it receives a message, and as you see here, it can be get, post, put, whatever you want. I can limit that. And then I parse what they send in. Here I'm going to route it because this I want to send to LLM. And I have Google Gemma reply to it. So Google Gemma, clean it up, make my prompt, cold gemma, get the results back. Again, push it into Kafka so I can, have a copy for someone else. And then we return it to that REST endpoint, which is the response here. We send that response back to Flink, and it shows up here. And as you see, that ran pretty quickly, even with all that round turn. That's really it, what I want to show you. Thank you for attending this talk. I'm going to be speaking at some other events very shortly. If you're in the area, if you're in New York or Seattle or Boston, say hi. It's been really good showing you what we could do today. Thank you.